This conference will now be recorded.
Thank you, Ankita. Also, then why don't you install 3.6? Any version which is 3.6? You can uninstall and then install, or you can wait for some days. ggplot will be available. As of now, it might not be available, but in some days it will be available for R4. So if you have already installed R4, then just wait for few days, probably 1 month or so, and then you can install gplot. Otherwise, for up to 3 point any version, it works. ggplot 2, yes. ggplot 2. So ggplot is not available for quite some time. ggplot 2 is also not working. Install.packages ggplot 2. ggplot or original ggplot, it has been original ggplot is not there for quite some time. ggplot 2 works. ggplot, not ggplo. Okay. Okay, so today we will start with basic statistics, and this is basically so coding is one part of learning data analytics, but another important part of learning data analytics is basically statistics. Now, what is statistics? What is the job of statistics? So for quite some time in our world, the computational facilities were not that strong. So when the computational facilities were not that strong, people used to find out that how will I get an inference about a huge data set, because I cannot calculate data from the huge data set. And oftentimes, like for example, for a country like India, collecting data for a huge country like India, let's say I want to find out the average income of the people here. If I have to go to and ask every person that what is your average, what is your income, and then I have to do an average, it becomes a Herculean job. And we do that kind of a Herculean job only once in 10 years. But then there are lots of decisions that we take in a daily basis. So if I have to take decisions on a daily basis and I do not have power of computation which is very high, or I have to create, I do not have the ability to collect data in such a large volume, then what we do is we create a concept called a population and a sample. So a sample is actually a representation of a population. It has all the characteristics of a population, but in a smaller way. When we generally try to collect lesser data, not of the whole population's data, but somewhat lesser amount of data we try to calculate. That's what when we do, we generally go for a sample. Now, what we try to do in statistics is to create an inference about the population, create inference about the population from the sample. So we do all our calculations in our sample data and create an inference about the population from whatever information that I get from the sample data. For example, let's say I want to know that how are you liking my class? So there are around 50 odd people in this class. So instead of asking all the 50 people individually one by one, I have to make 50 calls, which is difficult. I make 10 calls. So that 10 calls is calling the sample. Now, how I decided which 10 will be a different question altogether. We will discuss on that slowly when time comes. But as of now, let's say I call 10 people randomly and I ask them whether they like the course or not in a 1 to 7-point scale. And people give various kinds of ratings, 3, 4, 5. Now I get an average. Now, can I say that this is the average that also signals the overall average of the population, that means all the 50 people? If I am able to say that, then the sample makes sense. Then these statistics make sense. If I'm not able to say that, then I have to actually go and call all the 50 people. So statistics try to make sense from that information, which is generated from the sample, and they create inference. Statistics create inference about the population without calculating everything from the population. So that is the job of a normal statistics. So when we start statistics, we have to understand that there are certain basic measurements that we do. And one of the basic measurement that we do here in statistics is called central tendency. So this is one of the major thing that we try to find out. So what is the central tendency? Central tendency is the characteristics of a group, whether it is population or sample doesn't matter, a characteristic of a group which it's such a characteristics which gives the central core idea about the group. So it is such a characteristics of a group which gives me an idea what is the central core characteristic. That is something that the central tendency does. For example, let's say if I want you to explain anybody in this class, how do you define this batch? If I ask you, let's say I'm asking Amio, can you just write one line or 2 lines, 2 sentences which explains this batch of 43 people? How do you explain them? How do you describe them? Well, so interested in data analytics. So this is a core information about the batch. They are interested in data analytics. That means if I ask each of them the interest, the average interest will be very high. So that is the core information that I get from any description. So such kind of information, such kind of characteristics of a group, which gives me the core information, is called the central tendency. So how to measure the interest of data analytics? If I ask you, give me a quantitative measure of whatever you told. Interest in data analytics. How will you quantitatively give me a measure? So taste is not interest. Yes, spends more than 50% time with data. That is a very good idea. So I will ask you in your leisure time, how much time will you spend on data related articles, data related courses, data related this, data related that? I can ask you. And in your off time, how much time you spend? And if you spend more than 50%, then you are highest the data interest, and other guys who spends less than 50% are probably less data interest. And then if I take an average of all the people, then I might find out that the overall data interest is pretty high. So that is a quantitative measure. And now this quantitative measure, whether you spend more than 50% time with data or not, is your individual measure. When I try to find out the group's measure of that, we try to use something called central tendency. Some of the classic measures of central tendency is mean, median, and mode. These are some of the classic measures of central tendency. What is a mean? Mean is generally of various form, we mostly use arithmetic mean and geometric mean. There are other harmonic mean and etc. also there. I will not go into that. Arithmetic mean is nothing but let's say if I write mu is how we write arithmetic mean, is basically summation of xi divided by capital N, where capital N is the number of observations and xi's are the each ith observation. So xi is ith observation and capital N is total number of observations. So that is how we generally calculate arithmetic mean, which is pretty understood. Everybody knows that. So what will be the arithmetic mean of, let's say, 2, 5, 7, 9, 9, 11? Can you give me what is the arithmetic mean of that? It is 2 plus 5, 7, plus 7, 14, plus 9, 23, plus 9, 32, plus 11, 43. So 43 divided by 6 comes up to be 7 point something. So that's how we calculate arithmetic mean. Fair enough. This. Now, sometimes we also calculate arithmetic mean as a weighted average. For example, let's say in this class, let's say there are what is the message that will be? Yeah. So in this class, let's say there are 5 people who has given me this course in a 1 to 7 point scale. They have given me rating as 3. There are 6 people who have given a rating of 5, and let's say there are 10 people who have given a rating of 6. Then what is the average? What is the average, if I ask you? So then what do you do to find out this? You use a weighted average. So what is a weighted average? Weighted average is also one kind of arithmetic mean, which is mu is equal to wixi by summation of wi. So which we know basically, which is 5 into 3 plus 6 into 5 plus 10 into 6 divided by 5 plus 6 plus 10 comes up to be 15 plus 30, 45 plus 60, 105 divided by 21. Wow, this is 5. So that will be the average. So this is basically, this part is weighted average, and the first one is an example of normal arithmetic. Then comes a concept called geometric mean. A concept called geometric mean. So what is a geometric mean and what does it apply? So oftentimes there are some LIC agents who comes to my office, or different, not LIC always, different kind of insurance agents who come to my office. And they say that, sir, why don't you buy this thing, this particular policy or this mutual fund? And I ask them what will be the return. And they say that, sir, in year 1, we got a return of around 10.2. In year 2, we got a return of 4.5. And in year 3, I got a return of 9.6. So the average return is basically 10.2 plus 4.5 plus 9.6 divided by 3, which is comes to be 11, 13.1 and 24 divided by 3, so around 8.1. So which is a pretty good return, higher than our current rate of this thing, the fixed deposit, because fixed deposit gives me 4%, 5%, 6% return right now in this economic condition. So 8.1 is pretty good, why don't you? And it's very safe also. There is no equity component here, blah, blah, blah. So why don't you invest in it? So that kind of a thing this is. Now, this calculation is absolutely a wrong kind of a calculation. You cannot do this kind of calculation in all such kind of processes which are geometric in nature. What is geometric in nature? That means which are increasing in nature. For example, so what will be my average return? If I ask you what is the average return? So average return, if I say average return is R, then ideally if I invest 100 rupees, then I should get 1 plus R cube after 3 years. Do you understand this line? So if the average return is R, then if I invest 100 rupees now, what will I get after 1 year? 100 into 1 plus R. What will I get in after another 1 year? That into 1 plus R. And what I will get after another 1 year? That into 1 plus. So it's compounded, as simple as that. So now if I want to calculate that compounded, that will be 100 into 1 plus 0.102 into 1 plus 0.045 into 1 plus 0.096. Whichever R actually solves this equation should be my average return. Am I making sense? Whichever R solves this particular equation should be my average return. Anybody has a doubt? So in that case, should I go once more? Whatever I did here. Yeah, tell me. So what is this? When I say anybody has a doubt, nobody says no or yes. And when I say should I go once more, you are saying that okay, let's go. This should not be the case. You should be very straightforward in asking the doubt. We are going in the maths way, so you have to stop me again once more. So first year return is 10.2. That means if you invest 100 rupees, you will get 110.2 rupees. 10.2 will be your interest. Fair enough. Now next year the return is 4.5. That means if you invest 100 rupees, you will get 104.5 rupees. But you are investing in year 0, you are investing 100 rupees. Here you are getting 110.2. What will you get here? You will get 110.2 into 1 plus 4.5%, whatever is the value. This is your interest rate, right? 1 plus 1. This will be, and in here it will be 110 into 1 plus 4.5%, whatever is the value. This is what you get return here. Then another 9.6% you get, which is 1 plus 9.6%. Yeah, the return rate changes because some year the economy is boom, some year the economy is coming down. So economy is boom means your interest rate will go up, economy is coming down, interest rate will come down. So some year you get more money, some year you get less money. But this is how your money gets accumulated. Is it okay for everybody? Anybody has a doubt? That's what I have written in the right hand side. Now if I want to know what is the average increase over the third year, 1 year is 10.2, second year is 4.5, third year is 9.6. If I ask you what is the average return, average yearly return, you cannot do this. You have to write this. And if you have to write this, and if I try to solve the formula, solve the equation, then Then 100 cancels out in both the side, and 1 plus r cube becomes 1 plus 0.102 into 1 plus 0.045 into 1 plus 0.0 what 096, or r is basically the geometric mean of 1.102, 1.045, 1.096 minus 1. That will be r. What is the geometric mean? This is basically the multiplication 1.102 into 1.045 into 1.096 to the power 1 by 3 minus 1. So this is what the concept of geometric mean has an application. You have all learned the formula of geometric mean in your life. You should know also why it applies. So this is one of the situations where it applies. Why minus 1? See, 1 plus r cube. No, debunks 1 plus r cube. So I am now solving r. So 1 will be minus 1 will come in the right side. No? Yeah. So this is how, whatever be the percentage, I don't care. But this is how you have to calculate. So the value that this guy told me is probably a little bit of inflated value. If the variations are small, you will find out that this value generally comes to be a little bit of inflated. This one. Anyway, so that's how we generally do geometric mean. The next one is median and mode. So I will discuss about median and mode. Okay. So what is a median? Median is nothing but the exact median value of a series when it is, so median is basically the middle value when it is sorted. So you have to sort it. You have to sort by increasing order or decreasing order, doesn't matter. As long as the values are sorted, what will be the whatever is the middle value, exact middle value will be your median. So because the R is not GM, R comes from the geometric mean. The geometric means formula, as I written, geometric mean is basically multiplication of xi's to the power 1 by n. So here I multiplied 1.102 into 1.045 into 1.906 to the power 1 by 3. So this part is basically the geometric mean. Okay, so middle value. So let's say 2, 3, 4, I have some values. So let's say I got this. This is a series, some data. So what would be the median for this? There are 9 values. So fifth one will be the median. So the median is 7. This is my median. So then same thing. And let's say I have an odd, even number of values. The moment I have an even number of values, I do not have one single middle point. So let's say 6 values here, 12 values here. There is no single middle point. Middle point means the number of values in the right side and the number of values in the left side has to be same. The number of observations in the left side of the value means smaller than the value, and the number of observations higher than the value has to be same. Now here in this series, there is no single value which has that kind of a characteristic, that the number of values which are smaller are equal to that, and number of values which are higher and equal to that are same. None of them are like that. See, if I talk about 7, there are 1, 2, 3, 4 values who are smaller or equal to that, and 1, 2, 3, 4, 5 values who are higher or equal to that. And if I talk about 9, in the left side is 4 values, right side it is, left side is 5 values, right side it is 4 values. So that's why what we do is we find out two middle values, 7 and 9, and then take a mean of that. So mean of two middle values is my median. So as people are saying, 8 is my median. Fair enough, you already know that. Many of you probably will know that. The third one is mode. So what is a mode? Mode is used in case of mostly qualitative data, in case of category, I would say string data or mainly categorical data points, where it talks about the most frequent, so most frequently observed value is basically is your mode, the value that you see the most. So the same thing, if I just say 2, 3, 5, 5, 7, 7, 7, 9, 9, 11, 11, 12. In this observation, the mode is 7. Or let's say if by chance it had been like this, then the mode would have been 12. So the most frequently observed value. The quick question, which one is the best? When will you use which one? How will you know? So mean, median, mode. How will you decide which one I will use? So many of you already know mean, median, mode. There's no new thing for many, probably around 70% of the class. But I want to know that how will you decide at what kind of positions which one will you choose? And this is very, don't give me, Amrita, don't give me MBA type of answers. So depending on the data, obviously, but how? Let's tell me how. Yes, Prithviraj. So one thing you were saying, that mean is not so good when the data has outliers or data is skewed, which is good, which is a good observation. Let me just give an idea why that happens. We oftentimes see this kind of answers that in IIT there is a person, there are some students who gets 2.5 crore rupees of job, and so if I just draw the number of people who gets various kinds of jobs, so frequency and salary, there will be, most of the people will come here, and some people will come here, some people will come here, something like this. And then some guys are here and some few guys are here. So this is like, let's say around 10 lakhs per annum. This is around, let's say around 50 or 30 lakhs per annum. And this is 100 lakhs per annum. Now, if I just without considering this person, if I try to do an averaging, let's say 10, 10, 11, 11, 11, 12, 12, 13, 15, 18. Okay, so can you do an average of this, anybody? Can you quickly calculate the mean of this? So can anybody help me? Yeah, 11.25. Thank you. So 11.25 or 12.3. So something like that. I'm not sure. Two answers have come up. Uh, okay, 12.3. So many. See, I'm taking mode. I'm considering 12.3 because more number of people are saying 12.3. So this is a situation. Pooling is a situation when we go for mode. Okay. So we don't do weighted average of our, let's say, when vote happens. So who will be our prime minister? We decide based on mode, not based on any weighted average or pooling or any kind of mean or something like that. So just to give an idea when we use mode. Anyway, so yes, 12.3. Fair enough. So now, if I just put another person who gets, how many observations are there here? So here there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very good. 10 observations are there. Let's say there is one person who gets 100 instead of 10 in this particular series. So all of a sudden, then what happens? His average becomes 22.3. No, not 22.3. Let's say 110. Not 100, 110. Then the average becomes 22.3. All of a sudden. So before he was 10, now he is getting 110. The average from 12.3 shoot up to 22.3. But the median remains same. So the median, initially when he was getting 10, the median was around 11 and 12's average, which is 5. Now when he is getting 110, this will come here. So 12 and 12's average, the median becomes 12. So median is not so much sensitive towards an extreme value. So extreme value will impact mean a lot, but not median. So a good way to understand whether I should use but not median. So a good way to you understand which one can be a better measure is that you just check the skewness, that you just plot it and see that whether there are values which are very high or very low. So if that kind of values are there, probably median will be a better way. But what happens is, the problem is that there are various kinds of statistical analysis available where median cannot work well, because median does not consider the whole data. Median only considers the middle two values, that's all. So it is a I would say non-parametric test. Parametric means something that considers all the values. Now here it does not consider all the values. So then there are various kinds of analysis where we have to stick to mean and we cannot use median. Now, if that is the case, that there are, even if the data is skewed, you have to stick to mean and you cannot use median in certain conditions, then why we actually try to help something that helps us is called a deviance. So deviance is a measure of how the individual values are away from the mean. So how the individual values are probably away from the mean or scattered around the mean. That is something that deviance as the overall thing that measures. So if I cannot use median, then I can use the mean, and along with the mean I can say that this is the deviance of the data, The mean will give you the central tendency of the data, and the deviance will give you that how much you can believe that central tendency, how much credibility that central tendency has. That can be measured with something called deviance. Now, deviance is of different types. Some of the classic deviance we will discuss in this class. So let's say I have some values, three values. Let's say 2, 4, 6, 8, and 10. Their mean is basically 6. Now, I want to see that how the individual values are away from the mean. So I calculate a error which is x minus mu, a deviance, how much it is deviating from the mean. So this becomes -4, this becomes -2, this becomes 0, this becomes 2, and this becomes 4. What is the summation of these errors? The summation of these errors is 0. Why it is summation of these errors is 0? Because the negatives and positives are cancelling out each other. So when we generally calculate this summation of total, if I try to calculate the total deviation, I just cannot go for a summation of the deviations, individual deviations. I have to do something else. So what can I do to make sure that I am trying to calculate the total deviation? And individual deviations are coming like this. Alexander, Alexander and Arun Babu, are you with me? As of now, do you have any query? Manjari, okay, okay. So let's say I have these 5 values 2, 4, 6, 8, 10, and their mean is 6. So I'm trying to find out how the individual values are away from the mean. How the individual values are away from the mean. So how 2 is away from the mean? 2 minus 6, which is -4. How 4 is, how much 4 is away from mean? Mean is 6. The value is 4. So 4 minus 6 gives me -2, and so on. Now, if I do an average of this, I have to do a summation. And the summation comes to be 0. So that's why the average error is basically 0. And that does not give me anything. So what I can do, one easiest way to convert it to such a form such that the negative and positive does not cancel out each other is basically take a mod. I can take a mod. Fair enough. So then this becomes 4, this becomes 2, this becomes 0, this becomes 2, this becomes 4. It adds up to be 12. So summation of mod error is 12, and we call it absolute error. Mod means the absolute value. So mean absolute error, or we also tell it MAE, mean absolute error, or MAE, is equal to this summation of these errors divided by the total number of observations, which is 12 divided by 5, comes up to be 2.4. Check the calculation. I'm just waiting. So it's the mean of the absolute error. Absolute means taken a mod. I can do that. Now this 2.4 is one measure of deviance. So mean absolute error is one type of deviance. Instead of taking, I can also squaring it up. Many people suggested me to square it up. So I can do this. I can say this is 16, this is 4, this is 0, this is 4, this is 16, adds up to be 40. So square error, basically summation of error square is 40. So what is the mean square error? The mean square error is summation of error square by n, which is 40 divided by 5 comes up to be 8. Fair enough? 40 divided by 5 comes up to be 8. Now tell me that it is 2, 4, 6, 8, 10. Let's say this is your average annual income. This is your annual income, lakhs per annum. Then what will be the unit of the mean? If the individual values are LPA, then the mean is also LPA. Then this error square will be LPA square, not INR. I am saying LPA, lakhs per annum. This per annum also comes under this thing. It is not just the rupees. Rupees per annum. Is your salary is a rate. Your salary is not a price. It's a rate. Okay. So anyways, coming back to the question. So it is basically lakh per annum square. So I have to take a square root to bring it into the same this thing. So what I will do here is I will take a square root. So root mean, I will take a root of that. So root mean square error. I will take a root of this thing. Root mean square error. We call it RMSE. Is basically root over of this 8. That comes up to be something 2 point whatever, I don't know, 2.66 or something. What will be root over of 8? Can anybody help me? 2.82. Okay. 2.82. Now RMSE is also called as this MSE. Another well-known term of this MSE is variance. And another well-known term of RMSE is standard deviation. I never remember the standard deviations formula. I remember always the term called RMSE. So if I know that RMSE, R stands for root, then M stands for mean, then S stands for square, and E stands for error. This is the formula. So don't mug up, never mug up formulas. Try to understand it. That will be the best way to go ahead in math. So RMSE's formula is like this. It's exactly written there. Root. So first down put a root sign, then mean. Then that's why in the numerator put a summation sign, and the denominator put a cap n sign. Wait a minute, now I will come to that. Why, in which kind of situations it is n minus 1, not here. I will come to that. So as of now, the answer is no. It's full n. And then I will, at a right time, I will say when it is small n. Okay. And then x minus 2. Yeah, if you break it, if you break this mayuk, if you break this, it also comes up to be, I will not show you the derivation, but you can You can see the derivation later on your own. Minus or mu square, basically minus mu square. It also comes like that. It also comes like that. If you break it, it will come. Should I show you the derivation? Sometimes I become very prompted. So why the two formulas are same? Let me just give an idea why these two formulas are same. So what is this? I wrote summation x minus mu square by n. Can I write it like this way? Summation x square plus mu square minus 2x mu divided by n. Can I write it in this way? Just breaking it up. So basically 1 by n of summation x square plus mu square by n summation of that minus 2 mu summation of x by n. This is what I am getting. Ultimately, if I break it up, are you with me? Are you with me? Very good. So then 1 by n x squared. Now see the mean, this mu squared is a mean, it's a constant. So it's if I multiply, if I just add capital N number of constants. So if I multiply 5 on single value, 5 10 times, that will be 10 into 5. So if I add mu square, which is a fixed number, I changes but mu does not change. Mu is a fixed number for a group. So then this will be this sir, why is mean not summed with x? Because it is only one value. Yes, it's a constant value. And minus 2 mu, and then basically minus 2 mu square. Let's check what I have written. Minus 2 mu into mu. This part is also mu. This part is also mu. So 2 mu into mu. Fair enough. Now n and n cancels out. 1 by n's x square plus mu square minus 2 mu square is basically 1 by n x square minus mu square, the formula that Mayuk wrote. Never mug up a formula. Okay, it's a little bit. You have to take the courage to do the maths. That's all. Fair enough, no issues. Simple. Now, Mike, I will come back to the question that I was discussing. I wanted to discuss that I have shown you two different types of deviation. It's very important to understand when you go ahead in data science later point of time that which one is better. This mean absolute error is better that I have discussed here, or this mean square error or root mean square error is better. Means should I take an absolute value or should I take a square value and then take a square root later? Which one will be a better approach? Should I take a mod or should I take a square? And you have to say me why. You cannot just say the answer. You have to tell me why that is better. No, it is the absolute also covers all value. No, error is more in RMSE actually. In absolute it is 2.4. In RMSE it is 2.8 ultimate calculation, whatever you are getting. So as Preeti told, Preeti told it right, that it puts more penalty, more importance to the extreme values. What happens is, if I just compare these two guys contribution on this value 12. The contribution of these two guys value in this 12 is basically 2:4, which is basically 1:2. So these 2% contribution towards the error is in a ratio of 1:2. On the other hand, I just calculate based on the error square. These two guys contribution towards the error square is basically 16:4, which is 4:1, or if I do in the other way, 1:4. So here, for the same level of distance, I am giving more penalty. Here I am giving twice the penalty. Here I am giving 4 times the penalty. So I am giving more penalty in situations where I am using the square term. So as Preeti told, that we are penalizing more to the extreme values, or the values which are away, we are trying to penalize more. And when trying to penalize more, we are becoming more conservative in nature. And if I'm getting more conservative in nature, the RMSE scores will be higher than MAE scores. Always it will be higher, at least at when it's greater than equal to MAE. So because that will be the case, it is better as a statistician to use RMSE. Now, there are certain situations when the extreme values will not impact. There are certain conditions, certain kind of methods where the extreme value will not matter. So in such kind of situations, mean absolute error is also used. Yesterday, I was talking about two techniques, machine learning and econometrics. In econometrics, this extreme values has huge impact. But in most of the machine learning techniques, extreme values do not have much of an impact. So for machine learning techniques, we also use mean absolute error as our measure of error. But in econometric techniques, we use root mean square error, or basically standard deviation, as our measurement of error. Yes, because yes. So more smaller the RMSE value, the more I can believe on my mean value. So how this standard deviation helps at a later point of time, I will discuss in detail. Okay. So somebody was talking about small n minus 1. When I talk about population and sample once more, later point of time, I will also again start with sample and population once more. I will bring it this small n minus 1. Penalizing means giving more importance to the error. So let's say I am also scattered from the mean, you are also scattered from the mean. Okay. Now, how do I decide that whose scattering is more scattering? Let's say who is more away from the mean. When I am 2 kilometers away from the mean and you are 4 kilometers away from the mean, and I just measure in as a 2:4 way, then I am using this mean absolute error. But if I want it to be more congested, I want it to be very close to the mean, then I am giving huge importance, I would say more importance, to things which are away. So I am giving penalty, or I am giving basically weight, added weightage in a square term. So instead of doing a just normal mean, in case of RMSE, we are doing a weighted average, where the weights are also the distance. Okay, Divans, let me try to put it in this way. No, I'm increasing the weight of the outliers in my error square. So 100 become 100 square. Let's say the mean is 0, the distance is 100. When I calculate, it becomes 100 squared. So let's say, makes sense? Okay, fair enough. Okay. Okay, so coming back to whatever we were discussing before, there was a derivation. Now, so mean and standard deviation, or basically central tendency and deviance, we have discussed. Now I will talk about a little bit on probability. What is probability? So let's say I have three balls like this and two diamond balls. What is the probability if I blindly choose a ball from here? It will be a ball, that is 2 by 5. So basically, probability of an event is a number of options in which it may occur versus the total number of possible events. So this is the old school example of probability. This is what we all know for quite some time. Now you have to understand that that does not mean that if I blindly choose from this particular urn means particular basket, if I blindly choose 5 times, I will get 2 balls. That will not be the case. So how will I? So this is something that you can practice in a real life situation also. Let's say you want to toss a coin. You will see that when you start tossing a coin, any coin you start tossing, then it is not that if you toss 10 times, you will get 5 times heads and 5 times tails. But slowly, if you keep on tossing like this, and go on tossing, it will ultimately, let's say this is the probability of heads, and this is the number of tosses that you are doing. Initially, in the first few tosses, the heads will be high or the tails will be high, depending on what kind of this thing you are using. And then it may fluctuate. The probability will fluctuate over as we go on increasing. The numbers of heads will go changing. But if you go on doing this, after a certain time period, it will basically saturate to a certain point. This probability value will, yes, law of large, not law of large numbers, but yeah. So this is law of large numbers. So after large number of these things, it gets saturated. So that is, we call it, this is your probability, not here. After you reach this saturation based on law of large numbers, you will get the actual probability of a particular observation. So when I say I blindly choose something, the probability will be 2 by 5. That does not mean that if I choose 5 times, I will get 2 diamond balls. That just means that if I keep on doing this thing for, let's say, millions of times, then probably 20,000 time I will get, or 2 lakhs times I will get the diamond ball. Or for 1 million it will be 4 lakhs. Sorry. So that's what the probability is. Now there are lots of things that we have to know, understand, and we all knew it before, but I'm doing a recap on probability. So there is some concepts called, yes, Arun, please what? So do you have anything to ask up to this point? Ask me. Why don't we take 4 powers? Very good question. Actually, Avinav, I should ask you, because see, our two purpose was there, Avinav. One purpose is to make sure that the sign problem goes away, and second thing was to give higher weightage. So square things gives me both, means taking a square actually does both. Taking a cube will not do that, but taking a 4 times power, fourth power will also do that. But that much of conservativeness is not something that we generally practice. It's a general practice, frankly speaking, that much conservativeness is not required. Square can actually handle both the problems, the sign problem also, and the error giving higher weightage to more errors smaller problem also. So that's why you don't go for the fourth power. But yes, if you are very conservative, you should go to the fourth power. But in that case, that will be not defined as standard deviation anymore. You can name it as per your own way. Then maybe the data near the central line with no significance here. That's means too much weightage to things which are having. Anyway, so as by whatever we were, now I will come to the next part of probability. So there were certain concepts where we have to also think about certain conditions happening together. Let's say if I ask you that what is the probability that you are a boy, a male basically, and also wearing a spec. If I just, what is the probability that you are a boy? So probability, I'm asking that male and spectacles. So let's say in the whole world, if I consider this box to be the whole world, which is we call Venn diagram, these people, this many people, whoever is lying inside this circle are basically, so what I do is let's say I bring in all the people from the whole world and then put in this box. Okay, all the people from the whole world, I bring them and put in this box. And within that box, I create a sphere, a circle. And within that circle, only the male people are kept. So whoever is outside this circle, they are female. And then I create another circle where all the spectacle wearing people are residing. Now you are asking me that there are some parts of the circle which overlaps with each other. So these people who are in this area, in this zone, are people who are male also and people who are wearing spectacles also. So you are basically asking me what is that zone? What is that zone? So don't answer. Don't see. One good way of learning is to unlearn. Okay, Ankita, Pravi, and many other people. A good way of learning is to unlearn. You have to understand that you do not know. If you do not understand that, then you will answer like this. So be with me. Wait and see what is coming up. Don't try to answer. You should participate, but with some caution. So the answers are wrong basically. Pravi and Ankita, both the answers are wrong. So coming back to this thing, why the answers are wrong? Simple question is we do not have the probability. First of all, we don't have 50% male, 50% female in the whole world. You should be knowing that. First, being a female, it's a feminist issue for quite some time. So that is something that's number one. Number two is that we don't have 50% spectacle wiring and 50% non-spectacle wiring. And being in a gender and being wiring a spectacle might not be independent with each other. So all of these things will be there before you can answer that. So wait a minute. Anyways, so that is the area that I am trying to find out, this area. So if I say this is male and if I say this is spectacles, then that area is basically M and spectacle, or P of M and S. This is how we write this thing. So what is the probability that somebody will be a male and somebody will be wearing a spectacle? So this is how we write it, P, M and S, or M intersection S. Now the same question if I ask that what is the probability that you are male or you are wearing a spectacle? So the previous question was and now the question is or. What is the probability that you are a male or you are wearing a spectacle? So if I just go into this particular graph once more, this is the male guys and these are the spectacle guys. So if a person is lying here, will he be male or wearing a spectacle? Yes, practically he is both. So this area comes under whatever I'm saying. Now if somebody is here, whether he will be within this definition, he is a male, so he will be in this definition. So similarly, this area is also coming under this zone, whatever I'm saying. And somebody is standing in this area, he will also come into this definition? Yes, he is wearing a spectacle, so he is also coming into this zone. So basically the whole thing is coming into this zone. So here we write male or spec to be probability of male union spec. This is how we write it. Now if I have to write this formula carefully, you see that this zone is how much? This zone is this zone, whatever I'm drawing right now, this zone plus this zone, this and this. Okay, let me put a red color. The M plus this zone, that is my M plus S. So basically P of M plus this broken zone. Fair enough. Now what is this broken zone? That broken zone is P of S minus this zone, this green zone, whatever I'm drawing right now. That broken zone is basically P of S minus this green zone, and this green zone is whatever we wrote before. So this is the formula. You can actually see the graph in different other ways, doesn't matter. And that is how I get a formula of probability of male, probability of specs, and probability of male and spec. So by chance, if in the whole world, let's say 52% were 52% people are male, and let's say around 30% were spectacles. So then P of MUS is basically 52% plus 32% minus P of M intersection S, and I have to some way or other find out what this value is. I will stop for 1 minute for questions. Let's see what are the questions that have come up. Spectacles can be related to age, maybe. may not be also. So whenever we say maybe, there's may not be also. Fair enough. So as of now, any query? Okay, now something that I'm coming up, which might be a little bit difficult to understand, but very important to understand. So tighten your belts. Now, what is this probability of male and spectacle? This is something that I am going to talk about. So, what is the probability that you are a male and you are wearing a spectacle? So, let's say I have in the world 100 people. Out of them, 52 are male and 48 are female. So 52% and 48%. And here, out of this 52, 32 are wearing spectacle. So 20 are not wearing spectacle. And here, let's say 22 are wearing spectacle. So 26 are not wearing spectacle. Let's say these are the values that I have got. Then what is the probability of male and spectacle in this situation? In this situation, the probability is 32 divided by 100. Are you with me? Okay, very good. You are all with me. Fine. Very good. That sounds very good. Now, can I write this thing as 32 by 52 into 52 by 100? Very good. I can write this thing. So, what is 52 by 100? The 52 by 100 is probability of M. And what is this 32 by 52? 32 by 52 is basically, if I just write in normal language, that probability of wearing spectacle when you are male. Am I right or wrong? This is probability of wearing a spectacle when you are male. When you are male, how many people are there? 52 people are there. Out of them, how many are wearing spectacle? 32. So 32 by 52 is the probability of wearing a spectacle when you are male. Okay. So what is in this statement, probability of wearing spectacle when you are male? In this statement, what is certain and what is uncertain? Being male is certain or wearing spectacle is certain? What is already happened? Being male, it has already happened. And the stochastic part, the probabilistic part, is whether we are wearing a spectacle or not. So that's why we write in also in this language that instead of when, we write given you are male. Or we can also write in another language conditional to the fact that you are male. All these things, given you are male or conditioned to the fact that you are male, can be written like this. Probability of S given M into probability of M. This is how you write this thing, this language. So this straight line and then M means that conditional to the fact that you are male. This is the stochastic component. This is the given, which is already happened kind of a component. So given that you are a male, what is the probability that you are wearing spectacles? I will wait for 2 minutes. If you have any question, any query, any doubt, if you want me to repeat, let me know. And if you want me to repeat, also let me know from where. Good job. Yeah, Suraj, tell me. Very good. Good job. Very good. So then, can I write this? I have wrote this like this. M and S is probability of S given M into probability of M. Okay. This can also be written as probability of S given M is probability of S and M. See, M and S and S and M are same thing. You and me and you are two same thing. So I can write it in this way. Do you know this formula? Have you heard about this thing before? Yeah, so that is how the Bayes theorem comes up. So this particular thing is called Bayes theorem. We will use it quite a lot as we go ahead. So probability of A given B is probability of A and B. So that is the formula. That also means probability of A given B is equal to probability of A fair enough. So what will be the formula of B given A? Should it be the formula? Then can I write it like this way? Very good. So if I just told that A and B and B and A are same thing. So the left hand side are same in these two equations. So if the left hand side is same, then the right hand sides will also be same. No, that is okay. Ankit, the denominator will change. When you create the formula, the denominator will change. But forget about the formula. Just think about this two line. That probability that you are a male and wearing a spectacle, and probability that you are a spectacle wearing person and a male, these two lines are same thing, no? Just imagine a person who is a male and wearing a spectacle, and imagine a person who is wearing a spectacle and a male. You might probably imagine the same person. Yeah, so that's why if the left hand side is same, from the formula the right hand side comes, so then the right hand side are also same. That's how I get this thing. And if I get this thing, then I can say, okay, so then I can say that P of A given B Can I say this? So that is also another form, the one that I'm showing right now, is also another form of Bayes theorem. This is also Bayes theorem. Fair enough. Very good. So if I ask anybody in this class that, let's say you are doing my course, or any of you are a student in this school in ID, and you are doing a course with me. Okay. And let's say you are saying, sir, doing your class and passing the exam has no relationship with each other. You are doing this claim, making this claim that attending your classes and passing the exam has no relationship with each other. I will ask you how prove it. Why don't you prove it? So then you show me that, sir, these people, there are 10 guys or some people who have attended my class regularly every day. And there are some guys who have not attended any of my classes. Two groups of people, one attended and one not attended. And then you show that the probability of these two guys, these two groups, are X percentage and Y percentage, the passing probability. When will I say that my class attendance in my class and passing the exam has no relationship? In which condition will I say that? No. Come back to the example that I'm talking about here. Don't give me terms. When both are equal, when the chances of passing the exam by the group who has attended the course and chances of passing the exam by the group who have not attended the course are same, then I will say that there is no relationship. If by chance chances of passing the exam who did not attend the course is higher than who attended the course, means there are some people who attended the course and there are some people who did not. The did not guys percentage of passing is higher than the other group, then actually there is a negative relationship between attending my class and passing. So you will fail if you attend my class, since I'm that kind of a teacher. On the other hand, if people who are attending my class have a higher percentage than people who are not doing my class, then I'm a good teacher. But if these two percentages are same, equal, then there is no relationship. So all I'm trying to say is that A and B will have no relationship only when P of A given B will be similar to P of A. See, this also means this. These two things actually say the same thing. If P of A given B is equal to P of A, then I can prove that P of A is equal to P of A given B dash also. It can be proved. But that is the from common person's language. Do you agree with this? That let's say B is attending my course, A is passing. So when P of A given B is equal to P of B, which also means this, B dash means not attending my course, then this is a relationship. So this is called independence. When A and B are independent, this occurs. So when A and B are independent, this occurs. And you told me some time back, did you told this or not? Some time back, this is generic formula. So when independent, when A and B are independent, this is generic formula. This is generic formula. So when A and B are independent, P of A union B will be P of A into P of B. You know this formula, but you do not know the context from where it is coming. Probably you do not. I'm just assuming. So this is how it is coming. The P of A given B and P of A are same thing in case of independence. And that's why this formula holds true. So coming back to Ankita and I think Pravi or so whatever they told is 1 by 2 into 1 by 2, 1 by 4 when I asked male and specs. They actually had this formula and they didn't know that there are lots of other things that can come. Yeah, so please put yourself in mute. So I will wait for 1 minute again. If you have any question, let me know. So these are some of the things that we will be requiring. We will be taking into account. So based on whatever I told here up to this point, or whatever I will be teaching today, the maths part, there will be some quiz questions which are maths question, like statistics exam that happens in your course if you are studying in a college. So that kind of quiz will come. Just try to we cannot give lots of and one good way of learning this is to buy that book that I told, Levin Rubin, or any other statistics book. I personally follow Levin Rubin. I love that, but you can buy any other statistics book. You can probably download certain statistics books from basic statistics for management. If you write statistics for management, that will be better because then you will get business kind of questions rather than any other kind of questions, which will be more required for your job. So, but there can be other applications, statistics for social science kind of these things also. You should download them if you are not able to buy the book currently during the lockdown period, and then try to practice some problems from there. These are very basic things. Okay. Now, the next topic that I will be going to discuss is something called a probability distribution. Now, from here, it should be in probability distribution and etc. should be there in a BTech course also. But many of you have probably completed your BTech quite some time back. So a recap again might be required. So Suman, the name is Levin Rubin. Rastogi. Okay. Okay. Why don't we do one thing? It's so why don't I take just 5 minutes break? There's lots of talking was going on, and then I will start again. Yes, that one only. Let's take 5 minutes break and we'll come back. Thank you for coming back. So now we will be discussing something called probability distribution. Up to that, we will be discussing today. After that, I will be taking you through this what we call the visualization part, whatever we have left in the last class. Okay. So probability distribution is basically a functional or a graphical or a equation wise some representation of some kind of representation which says that how the probability is distributed
Sir, we can't hear you.
Hello, hello, hello.
Hello, sir, can you hear us? Hello.
Yeah, I mean,
Yes, sir, we
every
can hear your voice. We can
hearing
hear
me.
Yes, sir.
your voice.
Yup. 124, 124. Where'd the three go? There must be something wrong with the audio.
Hello. Hello.
Yes, can you hear me?
Yeah, we can hear you. Yeah.
Yeah, I'm very sorry. I don't know why this has happened. For the first time, the system crashed and I have to reboot. So I hope the recording is going on properly. I hope. I just see after the class. We'll see what we are. Okay, so I was planning to discuss something called. You can see the screen, I hope. So I was planning to discuss on probability distribution. So probability distribution, what it is that I'm going to say now. So probability distribution is basically graphical, or I would say, just 1 minute. The screen has huge lag. It's, you see whatever I have written probability distribution. Can you see that? Yeah, there might be some video lags. Okay, so let's see how it goes. Otherwise, okay. So what is probability distribution? Probability distribution is basically a graphical or I would say mathematical explanation or expression, which actually gives you an idea that what are the various probability of various kinds of observations. So there is something called, while we talk about probability distribution, there is something called a random variable, which we write as capital X, and a realization of a random variable. Let's say that is small x. Can you hear me, others? Can you hear me? So let's say there is something called a random variable, which is capital X, and there is something called a realization, which is small x. So have anybody known the story of Schrödinger's cat, or whatever? So can you just say what is that thing? So one cat has been kept in a box. Okay, a cat has been kept in a box, and the box has no holes, and that cat has been left there for some time. Let's say around 1 day or so. Now somebody asks, the cat is of a mathematician called Schrödinger, and somebody asks him that what is the state of the cat right now after 1 day you have kept inside the box, whether he is alive or not alive. So the mathematician replies that at this current moment he is both alive and not alive. So only after you open the box you know that whether this guy is alive or not alive. Till you open the box, the current condition of that particular cat is both alive and not alive. So this current condition of this particular cat in this story is a random variable. And once you open, can you hear me? And once you open the box and see whether that guy is alive or not alive, that is realization. For example, another example that I will give. Let's say there are 42 people in this particular class right now, and there are some people who are coming up and going away due to network issues. Some people have network issues. Sometimes they are going away, sometimes they are coming back, and so this 42 keeps on varying from 38 to 42. I'm actually seeing that because I have to take care of my class. Now, if I ask you what is the probability, so let's instead of probability, sorry, if I ask you that what is the gender of the person who will leave the class next? Now there are 42 persons. The gender of the person who will leave the class next. Now you don't know that. It can be either male or female. It can be a random value between male and female. Any one of them can happen. So this term, the gender of the person who will leave the class next, is a random variable. When somebody leaves the class, I find out his gender, and that is the realization. Another thing, let's say, what is the total number of increase in coronavirus that will happen today? If I ask you that, that how much increase in total number of infected will happen today. That's a random number. You don't know what that number is as of now. When the number comes up in the evening or at late night, then you will know that, okay, that is the realization. So any observation, anything can be defined as random variable and some fixed number of realizations. For example, the question that I right now asked, the gender of the person has only 2 realizations possible, or let's say 3 realizations possible, the male, female and others. In my class at this moment there is no other gender, so male and female. In case of the coronavirus increase, it can be any number between 0 to, let's say, I don't know, realistically 5,000. So any number between these two values. So all those values, 0 to 5,000, all those values are the realizations. Male and female both are realizations. Cat present or cat alive or cat dead is the realization. And the random variable is the see, Ashutosh left. So this is a realization. The gender that the person who has left is male. Fair enough? Oh, it just showed me that I'm not sure whether there is another Ashutosh. I have to check. But one message came up that Ashutosh left. Anyways, so now probability distribution is such kind of a mathematical expression which gives probability for all possible realizations. For example, let's say if I write that probability that Skozinder's cat is alive is 0.6 and probability now Girish Ranjan Mishra left, is that true? Probability he is dead is 0.4. Then that is basically, now GoToMeeting has gone mad. So now this expression, the one that I expressed it in this way, is a probability distribution. I can also draw it in this way. This graphical representation is also probability distribution. So it will be probability distribution only when I have P of capital X equal to small x for all x. I get this, and I also get this, that summation of P of capital X equal to small x for all x is equal to 1. So here 0.6 plus 0.4 adds up to 1. That's why I'm saying it is a probability distribution. If it was 0.9 by 0.6 plus 0.3, then I am not giving the probability of all possible realization. There is some other realization which has a probability of 0.1 which I have not mentioned here. By chance if it was 0.3. So then that would have been not a probability distribution. Now why that is required? So before I go there are certain terms which we call as probability mass function and probability density function. We have to discuss that. And before I discuss even that, I have to understand that there are certain variables, certain kind of data set which are continuous and categorical. Remember, we told in the first day that data is of 2 types, or in the second day, I don't remember properly. Data is of 2 types, categorical and continuous. Okay. Now, categorical data are basically of 3 types: nominal, ordinal, and interval. Let me give examples for this one and you will understand what I am talking about. So what is a nominal data? Nominal data is basically names, your name, your domicile's name, your state name, your city's name, any name is nominal data. It does not have any order. I cannot say that Mumbai is I can say Mumbai is larger than Kolkata, but I can only say that based on the size or based on the population. I cannot say the name Mumbai is larger than the name Kolkata, or there is an order of Mumbai, Kolkata, and Bangalore in terms of their names. I cannot say that. Or I cannot say Pritam, Ankita, Girish, Ashutosh, Manjari has an order. I cannot say that. So that is nominal. But then there it comes, your gender is also nominal. Then there's some stuff where there is an order involved, which can, so categorical data can take some specific data, specific values, set of values, but then there are some order involved. For example, like at scale, have you seen that highly disagree, less disagree? No, ratio is continuous. This is ratio. Okay, we'll talk about that, why it is also called ratio. So let's say like at scale. Well, I say that I give a survey and I say that how much do you agree that this GoToMeeting is a very bad platform? 1 means strongly disagree, 5 means strongly agree. And you give 1 to 5 point scale something. So some people ask me to use Zoom, but we have been asked to not use Zoom by our so our hands are tied. Then let's say I don't think I can teach 50 people using Google Meet. Yeah, that's right. WebEx is slower actually. I have tried WebEx in our platform, in our website. Actually, the WebEx comes to be much slower than GoToMeeting. Well, Microsoft Team is good. I have to try it sometime. I have tried it, but I have not taken subscription. I will check. Yes, WebEx is slower. I will try Microsoft Team next time. Let's see how it goes. So then like at scale, and then let's say somebody says low, medium, high kind of stuff. All things are ordinal. Then comes interval, which is where there are some intervals are there. For example, let's say I talk about age group. So age group means, so let's say 0 to 20 years, 20 to 40 years, 40 to 60 years, 60 to 80 years. So let's say income group, 0 to 3 lakhs, 3 to 5 lakhs, 5 to 10 lakhs, higher than 10 lakhs, so on. So these are all interval scales. How that is, how from nominal to ordinal comes? When along with name you have some order, you get ordinal. When along with order, you can do a little bit of, you get an interval, you can get a, so when you get an interval, you can do a mean of that interval. That 0 to 20, you can say that the mean is 10. And then you can do some kind of weighted average, some mathematical calculations using age group. So from slowly from the left side to right side, if I move, the characteristics of numbers comes in. Nominal has no characteristics of number. Ordinal has a characteristic of number, that is numbers are ordered, so ordinal is also ordered. Interval, you can do at least summation or subtraction using interval data. Like you can find out what is the average age based on this age group data. But then the last one is ratio, which is continuous variable. Why it is called ratio? It is called ratio because you can, there is a meaning of ratio here. Let's say one observation is 2, another observation is 5. You can say that this observation is 2.5 times the previous observation. So this ratio, this 5:2 has some meaning. Here 20 to 40 is to 0 to 20 has no meaning. Here high is to medium has no meaning, mathematical meaning. Here let's say the Ankita is to Pritam has no meaning. But here the ratio has some meaning in it. So we can do multiplication and what we call division using this data. That's why it is called ratio. What are the examples? The examples can be, let's say, the temperature or your age or let's say growth rate. So these are all basically continuous data. Fair enough. Now the problem with continuous data is that in case of continuous data, there is no, it will be still nominal. Yes, it will be still nominal. 0 and 1, if I just put, I can do some mathematical analysis with that 0 and 1 using dummy variables, but by definition, it will be still nominal. Now you have to understand that continuous data can take any number of values. When I say temperature of today in let's say in your home, what are the possible values it can take? That temperature, it can take any value between let's say 10 degrees centigrade to probably 50 degrees centigrade. Any value in between that. It can take 42 points. So how many total number of values it can take? How many unique values it can take? The temperature of today. Infinite. It can take infinite unique values. And what are the problem if it can take infinite unique values is this P of x is equal to x for all x is not available. Why it is not available? Because P of x is equal to x is basically n x is equal to x by capital N, right? Now what is this capital N? What is the, if capital X is temperature and small x is let's say exactly 30 degrees centigrade, then what is this capital N? What is this value? What are the various possible numbers that can take, temperature can take? It is infinite, and that's why whatever value comes here, this is always 0. Okay, fair enough. So that's why we cannot do the classical, and this summation also does not work. Summation of all x also does not work when the number of x is infinite. So instead of summation, what do I do then? Instead of doing this, we do an integration from x is equal to minus infinite to plus infinite, something like that. This has to be equal to 1. So I will not focus on the integration part today because many of you might not know what this thing is, but you have to understand that it does an integration, it does not do normal summation. Okay, so coming back to whatever I was talking, that probability distribution, there are 3 different types of probability distribution that we will be teaching in this particular course. 2 under categorical, which is binomial distribution and Poisson distribution, and 1 under normal, one under continuous, which is basically normal distribution. If time permits, we will also go for exponential distribution. So these are the mainly 3 things that I will do. If time permits, I will also discuss about this. in the next class. So this is what I will stop today. This is what I will stop today in terms of the maths part. The previous recording might be there, but the previous this write-up, the PDF file that I will be right now generating is lost, frankly speaking. When this I forgot to save. So you have to refer to the video for the probability part and the standard deviation and etc. part, which we did today. So now let's open whatever we were discussing in the last class. Whatever we were discussing in the last class, which was about the visualization. So I will open the file first. Just give me a minute. ggplot.ts, ggplot2 basically, yes. So that we remain in the same page, please clean your console. Please clean your environment also. Clean your console, clean your environment. Set working directory to source file location. And then probably so we have done up to bar plot. So I will run all the codes up to line number 28. So up to line number 28, you can run all the lines so that we remain in the same page. So we have created some bar plot, some line plot, some scatter plot as of now. So all the plots are here. So this is the last bar plot which we have done. So right now what I will do is that I will clean the plotting area. So there is a brush sign in the plotting area also. I will clean the plotting area. So there is no plots anymore. And I will start from line number 32. So now first what we are running is something called a histogram. The simple formula of histogram is hist, which gives me a histogram which looks like this. Very easy to look. You can export this picture as image and etc., or copy it in a clipboard, and then you can crop and do whatever. So those kind of stuff you can do. But generally we do not do all those stuff. So R is not generally not used for report creation. There is R markdown which you can learn later once the course is done. There is something called R markdown which creates very good, nice looking reports or charts or even web pages. So which you can learn, but that is not part of this course. But I will share certain resources with which you can learn how to create nice, good looking reports or web pages or web reports using R. Okay, so histogram, the same thing if I write with qplot, it looks like this. So the bin width I have set, you can see that the runs, most of the runs are lower and some of the runs are higher. So that makes sense because you don't do a half century or a century every day, even if you are searching to do that. So most of the runs are smaller, and the most common run is, what is the mode? Can anybody tell me what is the mode? Not 0 to 4 actually. 0 to 4, yes. Yes. So the same thing, if I use ggplot, the code is line number 34. Fair enough. Now there is something called box plot. Box plot is something which gives you the, okay, so to understand box plot, we have to understand that there are things which are like the median, the upper quartile, the lower quartile, these kind of things we have to understand. What is quartile? This term we have to understand. So quartile, what is quartile? What is percentile? Anybody? Have you heard about a term called percentile? What does percentile mean? That's percentage. What is percentile? Yeah, percentage of population below a certain value. Yes. As Siddharth told, below, not always below, equal to or lower than a certain value. Okay. So how many people are equal to or lower than a certain value is basically percentile. So if I got 75, I got 75% marks in the class, in the course. But it might be the case that 90% of students have got lower than or equal to 75. So then my percentile is 90, though I have received 75 percentage marks. So percentile is percentage of observations which are equal or lower than mean. That is percentile. Now then, what is the percentile value for median? The percentile value for median, anybody else would like to answer? Is it 50, as Siddharth told? Yes, because 50% people, it's a middle value. That means 50% people are lower or equal to the median. Now 25 percentile is called 25 percentile is called a lower quartile or quartile 1, lower quartile, and 75 percentile is called upper quartile. And upper quartile minus lower quartile is basically interquartile range. Upper quartile minus lower quartile is called interquartile range. This is also another measurement of deviance. Generally, when we use median, we use interquartile range as the measurement of deviance. When we use mean, we use standard deviation or mean absolute error as the measurement of deviance. So interquartile range is a measurement of deviance when we use median. Okay, upper quartile and lower quartile. Now, what is the median of the lower half? If I have 11 observations, do you understand that median will break a set of values into two halves? The median of the lower half is also lower quartile or 25 percentile. So let's say I have observations like this: 2, 3, 5, 6, 7, 8, 8, 9, 8, 8, 9, 9, 11, 12. Let's say I have values like this: 2, 3, 5, 6, 7, 8, 8, 9, 9, 11, 12. What is the median here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The median is basically 8. This guy is my median. Right? Actually, I've seen when this guy is my median. So then, what is the middle half? The lower half is this: 2, 3, 5, 6, 7. So 5 is the lower quartile. The value 5 is the lower quartile. And similarly, value 9 is the upper quartile. So 5 minus 9 is the interquartile range, which is 4. You understand that how it is coming? So box plot is a plot. Box plot is a plot which gives me this upper quartile and lower quartiles. So let's say this box. If I think about this particular fat box, do you see my cursor moving? My mouse moving? Okay. So in this plot, this part, in this plot, this is my median. So the value of the median is around 80. This is my upper quartile. This is my lower quartile. Okay. And this is my, this straight line is my outlier upper limit and outlier lower limit. So median, there are various ways of calculating this thing, outlier. I think here it is used in this way, not median, sorry. Here it is used in this way: mean plus minus 2 standard deviation is what we not an outlier. And why that is the case, I will talk about later, how this 2 standard deviation came in. So this value is mean plus 2 standard deviation, and the lower value is mean minus 2 standard deviation. And these dots are saying that whether there is any outlier in the data set or not. These values are saying that whether there is any outliers in the data set or not. So here what I have plotted basically is Sachin's runs over against various kinds of oppositions. That is what I have plotted. Sachin's runs. How are the outliers calculated? So we calculate whether the value is outside mean plus minus 2 standard deviation. Within mean plus minus 2 standard deviation, and some other people, if you are conservative, you will take 2. If you are less conservative, you will take 3. Yes, 95% of the data set. Yes. How that 95% comes, as Asutosh told, I will discuss later. Oh, this circle is actually what the chat is coming for me. I don't think you are able to see that. So how that 95% came in, as Asutosh told, is something that I will talk later. But mean plus minus 2 standard deviation, within that anything is not an outlier. Outside that something is outlier. Okay. Now can you tell me, yes. This circle, the small circles means observations. The small circles means observations which are outside. So just tell me, what is the median score of Sachin against Australia? Around 30. Fair enough. So this is, what is the 25 percentile? Around 10 or 15. What is the 75 percentile? Around 65, let's say. And what is the range? What is I would say the not range, what is the upper limit of and lower limit of his outliers? So from 0 up to around 140, let's say, or 143. And the one single score that he have scored against Australia above 150 is an outlier. 175. Okay. So Atul, can you tell me how many he has played against Bermuda or against Namibia? How many matches did he play? Only one match. Only one match against Bermuda. Only one match. Then that makes the same thing as median. Okay. And which against whom there is lots of outliers? So generally he has scored low, but in some of the matches he has scored high. So these values basically, which is not visible in this particular thing, which is not visible. Let me just make the plot bigger and see whether those things come up or not. Yeah, so this is against South Africa. See, if I just erase it and then, so these values are basically against South Africa. Okay, got it. So that in the third last plot from right, what does the absence of dotted lines signify? The absence of dotted lines means there is no, so the outlier, the upper quartile and lower quartile range means not the upper quartile and lower quartile within that the means your upper quartile and mean plus 2 standard deviation lies at the same place, or basically your mean plus 2 standard deviation is lower than your upper quartile. Now what does that mean is it's very much congested. I would not say it's congested, just let me think. Yeah, maybe your mean is low than your median, might be the one observation. Can this individual box plot, they're outliers, outliers. Can this individual box plot be represented as PDF with the line as median, and the total box plot representation is accumulation of different PDF with different axes? I have not understood the question, and it's make it simple. Okay, so I will just draw a box plot using ggplot while Anindo writes his question. And so now I have plotted based on the result of the match, and you can see that what is the contribution of, so Sachin scored high and India lost are basically outliers, which is a very nice thing to see, that Sachin scored high in many matches while India lost, but those are basically outliers. Okay, so that is something that you have to understand. Generally, and in all matches where India won and all matches where India lost, the median score is higher for matches where India won. So his median score is higher. So some of the observations that we would get. Yeah, you can make all these inferences. I'm not coming in the inferences right now, but yeah, means I would say that Sachin has quite a good contribution towards India's winning, because otherwise this would not have been so many outliers in the lost. Which one? Of what? I don't get it. So I means just check which you have downloaded. Have you downloaded the RStudio free version, or you have not downloaded the RStudio free version? Please uninstall and install the RStudio free version. And this is another plot, which is violin plot, which looks very very peculiar, but it has some meaning. So this is basically, if you rotate the picture, this is basically the way of representing multiple. Let's say this is a straight line. I cannot draw a straight line in a digital pane. So this is a straight line, the middle line. So this basically is a histogram. This part is a histogram. So you will see that when India lost, Sachin actually majorly scored lower. The frequency is higher in this point and lower at the top point. here in this circle that I've drawn has higher frequency. So the violin is like this. That this side it is the frequency, the width is the frequency, and the height is the run score. The height is the run score and the width is the frequency. Similarly here, this is the histogram. If I just write a straight line, this much is the histogram. This part is the histogram. This is how. So if I convert it to a histogram, it will actually look like this. Okay, this is the histogram, but this is the frequency, and this is the runs. So here, these are the run score, and the width measures the frequency. So in case of tide, you will know that Sachin has either scored low or scored very high. Either scored below 50 or scored above 100 when India tied a match. And when India lost a match, he majorly scored low. When India won a match, he has some values which are high. So just compare this one, the first one and the fourth one. Just compare the first one and the fourth one, and you will get an idea that whether Sachin has a contribution on India's winning or not. So you see that in the first one, his major focus was, so he has scored lower. So whenever he scored lower, India lost. Whenever that lower scoring frequency has come, so he scored a little bit higher, the score went up, and India won. So some I would say graphical representation of that. So value plot helps when you have to draw multiple histograms together. In a later class, I will discuss that in a regression equation, your variables x and y, means independent and dependent variables, all have to be normal distribution. So you have to draw multiple histograms in one go, because histogram will give the bell shape. If that bell shape is there, then you can say that it is a. So that bell shape, if I convert to a violin plot, it should look like this. See, generally the bell shape that we call, many people have heard about this. This is the bell shape. If I convert it to a violin plot, it should look like. This is a violin plot. Yes, normal curve. Yes, for normal curve, which is bell shape, we'll talk about that in the next class. But this curve can be converted to this. Now it is showing all of a sudden Swagata Chatterjee has left, and I'm here. Thank God. I'm left in a different way. Okay, now let's come to the curve plot. So curve x squared or x cubed, so often curves, if you have a equation, if you want to plot that, you can just use this function, curve is equal to x squared. And so I've drawn two curves. This red one is x cubed and this one is x squared. And you can draw curves. You can draw further bad looking curves also very easily, just by writing the formula of that curve. So nothing fancy. I will quickly go to pie chart. So let's say I want to know that what are the different kinds of dismissals Sachin has got. So I created a table in this line, for line number 47, with S10 data, I created table of dismissal. So if I just run this line number 47, and then I check what has been created, I will get a table which is nothing but the dismissal types and their count. So table creates a count kind of a variable. And now with this count, I can create a pie chart with a function called pi. So which creates a overall good looking pie chart. Now, if you do not like the color, you can put your own color here. Like I have written the color names, and I am not a good person in terms of what color to choose. So I wrote something. The things might not be that good looking, whatever comes, but you can create a colorful pie chart as well. So all you have to do is create a table first, 2 lines code, and then you can create it. And sometimes we also plot something called a so rainbow. Means I do not write the color on my own. I just write rainbow 8. That means choose any 8 colors from the rainbow. So rainbow is a color naming package that they have used. And levels also I can change. So levels I can change as dismissal frequency. So if I just run this, just check what is coming. Line number 51. Okay, wait a minute. Names of so that's what, yeah, I'm not, I've done it right, no issues. So here what I've done is, sorry, I will just run once more. If here what I've done is I've written color rainbow is equal to 8, and instead of I giving the numbers, he has got the, so dismissal frequency is like how to put levels. Let's say instead of this dismissal frequency, whatever is the heading, let's say this heading, this bold, caught, hit wicket, LBW, run out, this heading, I want to have different headings. Let's say I want to have headings like, let's say S T U V W X, some other headings I want. So I can use my own headings. That's what I wanted to show. The levels, this thing, what is the use of that labels? I just wanted to show that. So I can give the level names on my own instead of asking him to use. Got it? Now, if you want to put, because you can give level names like this, if you make the level names like bold 68 instead of bold, if you make bold 68, then you are making actually joining them and use that as level. So what I'm doing here, let's say I'm using a paste function. What is paste function? Paste is a function which pastes two things. So let's say Swagato Chatterjee and separated is equal to space. It will be giving me a text like this. It will give me a text like this. Let's say instead of separate, I write underscore. It will give me this. So this is basically, in Excel you write A1 cell and A2 cell, which joins whatever is the text in A1 and A2 cell. So basically joining two strings. So here, what I'm joining, you see the names of dismissal. What is names of this dismissal? Names of dismissals are these headings. And then I am also joining the dismissal frequency. I'm joining them, the values. So basically these values. So these values and this thing, if I join them, and this /n means there will be an enter. There will be an enter, and separator is equal to blank. Now if I just join them, what I'm getting here is basically this: bold, caught, hit wicket, retired, not out, and so on. Now I will use these labels, LBLS column that I have created in my labels is equal to that. So if I just run this line now, what do I get? I get a pie chart where the corresponding values are also written. You can also write the percentages if you want. Obviously, these are older ways. There are other pie charts which can give it automatically, but I am just showing. Similarly, I can create 3D pie charts also. If you want at all, you can create 3D pie charts, which looks like this. So you have to play with it to know. So all the thing that I change is, instead of pi, I wrote pi 3D. There is something called radial pie chart. Let's understand that. Radial pie chart is very. So let's say this is a radial pie chart. So what it does is, it's not only breaks. So see, radial pie chart is not breaking the. What does pi's job? Pi's job is to break the circle in various angular cones, where the angle of the cone is proportional to the value, right? So the pi size, the angle of the pi will be higher if the value is higher in the normal pie chart. But in this pie chart, the angle will be same for all, but the radial distance will be different. When it is used, this one is used when, let's say, you have lots of values which are very small. Let's say in a normal pie chart, when the values are very small in comparison to other value, then many small values actually not even visible, becomes not even visible, right? If you just check, I will just show you the pie chart. Can you see the hit wicket at all? Hit wicket or stumped, these one are not even visible properly here. Now, if those type of observations were much higher, means like there are hit wicket, there is stump, there is some other kind of run out, and on retired not out is also not visible, you see. So these are not visible. Why? Because they are very small observations. Now there are situations where those kind of observations are very small but very large in number. Let's say I try to plot a graph, a pie chart of market share of various retail companies in India. Market share of various retail companies in India. If I try to plot that, there will be so many retail shops in India which have very less market share, but their number is very high. So then those kind of pies will be lots and they will not be visible. Let's say if this is the market share, let's say this is Aditya Birla, or then this is, let's say, Reliance, and then this is Big Basket, Big Bazaar, and this is Amazon, and this is somebody else, and then the others will be basically small people filled up like this. Now, which will not even be visible. So that you don't face that kind of a problem, we use something called a radial plot. So radial plot actually does not break the pie, does not break the number of the overall this thing into equal, I would say, angle. The angular differentiation between the values will be same. That means the distance between LBW and heat wicket, angular distance, and the angular distance between heat wicket and cot and board is same, but the radial distance is different. So that's called a radial. I'm coming to that. I've not done it there. Up to 62, we are done. Now, let's say if I want to break the plotting area, I will just, before I do that, I will clean my plotting area. Let's say I want to break the plotting area and I want multiple plots together. So what I'm doing here is breaking the plotting area into 2 rows and 2 columns. Now what happens? First I draw a histogram. Oh, why it is coming error? Just 1 minute. Just 1 minute. Oh. The radius is proportional to the values, Abhinav. Yeah, it divides the plotting area. Just 1 minute. I will just put it in a. Figure margins too large. Are anybody else getting this thing? Figure margins too large? So I will solve the problem. Ankita, you are not getting, right? Ankita, can you share your screen, please? Means your graph is coming properly, right? Yes. So when you run that 4 lines, this is what you get. If you can see here properly. So first of all, main is equal to histogram of walls faced is giving you the histogram properly, and then the main is equal to histogram of walls faced is the heading. So when you have to write anything, main gives you the heading, and then I am actually plotting 4 plots. Can you zoom the plot? Ankita, can you zoom the plot? No, not there. See, there is a zoom sign beside export. Yes. So these kind of plots you can create in one go using this, which is an advantage. Sometimes this is used for creating reports. 1 scatter plot, 1 box plot, and 2 histograms, and you can create other types of plots also. Doesn't matter. Now to get back to the old one, can you close it? Going back to the old one, please run line number 63 by changing 2, 2 to 1, 1. Just run line number 63, copy that line, and paste it in console. Line number 63, copy it and paste it in console. And change 2, 2 to 1, 1. Yes, 1, 1. Now I have come back to the old way. Now my margins are set. Clean your plotting area. Clean the plotting area. Okay. Now if you again plot, the next plot will not come like that. Now if you plot the histogram, just line number 64, can you run? Yes. See, we have come back to the old one. So that's how we can switch from by breaking the plotting area from one go to another. Can you come down? Line number 70. Okay. What is this? Okay, so why don't we run line one by one? So see the levels of, what are the levels of S10? Just check line number 72. What are the various types of dismissals that we have? So you see there are hit wicket and retired, not out, and run out. These kind of things which were very low in frequency, I am changing in line number 74. I am changing them to others. Line number 74. So I'm changing the low frequency ones to others. Now if I plot now line number 75, I get a bar chart, simple bar chart, where the others have come up. So bold got others, LBW run out. The 3 or 4 guys have converted to others. Now I can also create this line number 79 or 77, 79 I would suggest. You see what is new here? The extra thing that I'm doing is fill is equal to blue, which I'm writing it extra. Or if I run line number 77, line number 77, fill is equal to red for bar charts. So fill, instead of in qplot or ggplot also this will work. Fill gives you that if you want to color it. Okay, go ahead, come down, scroll down. 94, check what I'm doing. Now this is a subsetting. So I asked you in the last class, wait a minute, Ankita. In the last class, I asked you that how to subset a data based on others in your assignment, if you remember. So here I am subsetting S10 and saving it in S10A based on dismissal, such that the dismissal will be either bold or caught or LBW or not out. So that means I am removing the others one in the dismissal data. I am only considering such rows which has dismissals other than, so I have 452 observations in S10. In S10A I have 405. 47 observations got removed. Now what I'm doing? Can you run line of 96? So I am removing that one and putting a green. So red, green, and etc. I can further subset it based on opposition. See line number 98, I'm subsetting it based on opposition. I'm choosing 3 oppositions only: Australia, South Africa, and New Zealand, which has only 168 observations. That means 168 matches he has played against these 3 guys. And now what I'm trying to plot is a point plot, a scatter plot of balls faced and run score. Then you run line number 99 and 100 together. 99 and 100 together. Yes, good job. So it's a scatter plot. Just check what I have done. So GOM underscore point makes it a scatter plot, a point plot. Then XLab balls faced makes the balls faced as my x-axis name. And YLab run score makes the y-axis name as run score. Lab titles is balls first versus run score. Make the plot title as like that. But what extra I have done here is color is equal to opposition. In the aesthetics, x is equal to balls first, y is equal to SR is something that we have done previously. The extra thing that I have written is color is equal to opposition. So all the dots which are Australia will become blue. All the dots which are New Zealand will become green. And all the dots which are South Africa will become blue. And I can create this kind of a chart like this. So there are various ways. I would frankly speaking ask you to keep on playing with it. Now go to line number 103, 104. Together, I am subsetting data in such a way that the result is either won or lost, and the opposition are these three oppositions. The number of observations is 160. Come down, scroll down. I am changing the result and opposition to factor form. I think they are already factor, but still 106 and 107. And then I am creating a Valin plot where field is equal to opposition. That means for the three guys, the field, remember field is equal to red, gives me the red field. Now if I write field is equal to opposition, it gives me each opposition wise different kind of color. So for dot, you have to write color is equal to that, dot and line plot. For bar chart, it is fill. For point chart or line chart, you have to write color is equal to whatever, red or opposition. Or in case of bar chart and violin chart, or let's say box plot, you have to write fill, means where the area is involved. You have to write fill. Fair enough? Can anybody tell me what this next line is doing? So cron is a library. Like we write library cron, we can also write recur cron. Run that line, Ankita. Okay, and then run 112 and 13 together. So cron actually reads the year separately. So for various year, I am separating based on the start date. See, factor, your x-axis is what? Your x-axis is in the code you see, I have written instead of x is equal to factor year start date. You see in the code, at the bottom you can see the code. At the bottom you can see the code in the console it has run. X is equal to factor years start date. That years within bracket start date comes from this cron library. Years within bracket start date changes a date to a year, and that year function comes from the cron library. So here in my x-axis various years are there, and y-axis the runs code are there, and you can see that Sachin had a good bronze score in 94, and probably so whenever World Cup happened, 94 was World Cup or 96? 96 was World Cup, right? Okay, so then my hypothesis is not right. I thought in the World Cup year he scored better, but probably there is means there's ups and downs. All I'm trying to say that he was obviously it's difficult to become consistent over such a long career, and there was ups and downs, and you can see when there was ups, when there was downs. Okay, go ahead. Close it. Okay, now in this one, I am using the scale color. So just run it. You will understand what it does. Run it. So here the scale color values, instead of color is equal to result, we have taken scale color values. Values is equal to, can you scroll in the right side? Can you move it to the right side? So instead of just writing the result, I have wrote the result, which color, how it will be look like. So here the labels have been changed in this line. Can you run the next line also? You will understand what I am doing. There's some here. You see this previous one was scale color manual. Here I have given scale size and shape manual. Size manual and shape manual. So in line number 170 and 171. So the shape manual is lost is equal to 15, bone is equal to 12. So there is a manual, what kind of shape it will take, and you can search for that manual. You can just write in Google ggplot shape manual and search for it, that which shape corresponding to which code. So 15 is corresponding to basically square, and shape triangle, inverted triangle is 25. And correspondingly the size is also there, the color is also there. So all of these things are I can change if I want. Run line number 124. Yes, that one. So I can change the levels as Har and Jeet also. If you can scroll in the right side, 124, instead of born and lost, which is there in the data set, you can choose what you want to write. So I would suggest that you mix and match, you play on with these things, and not only with scatter plot, with other kind of plots also, and you will find problems. You will definitely find problems, and with those you try to solve the problems when you go ahead. Okay, quickly subset it. Yes. Now please clean the plotting area. Now one by one, from 134 to 138, one by one you run. So first I have drawn a normal bar chart with innings, first innings and second innings in the x-axis, and count in the y-axis. So how many first innings he has played, how many second innings he has played, that is there. Next, I've changed the color to be red. Next. Now the extra thing that I've bought in here is basically the position is equal to fill, means just 1 minute. Okay, so fill is equal to result. The fill is equal to result. This is what I have brought in now. So that whole first innings he played and second innings he played will be broken. The fill, the fill will be broken between first innings, won or loss. Can you copy this line number 136? Please copy line number 136, paste it in your console, and remove this position is equal to fill. Position is equal to fill. That part you remove. Delete up to the comma. Remove the comma, bas. Now run it. Now, okay. So this is a better version. In the previous version, what used to happen is, it's like this. Just 1 minute. Huh? So in the previous version, we used to get the lines and etc. in a different way. Means we used to get some blue, then some red, again some blue, again some red. That position is going to feel actually sorts it up. Now they have done it automatically, so I don't think that is required anymore. Anyways, 137, line number 137. See that now we will get a beautiful looking this thing. So see what we are getting. Now what I am doing is I am creating a single line extra, which is facets. Facets, and then I am writing year, opposition tilde year. Opposition tilde year means that in the whole data that you have created, the whole previous chart that you have created will be broken in the x-axis based on opposition. You see the rows are opposition, Australia, and then England, then Sri Lanka, then South Africa, and then Sri Lanka. These are the oppositions. And then the y-axis is based on the years. So can you tell me how many, this is the count, right? Yes. So how many matches Sachin has played against Australia in 1990? How many matches he has played against Australia in 1990? Very good. So you understand that. How many matches he has played against Australia in 1998? In 1998, 7. Very good. No, so that 0.5 you can just, that's 7, huh? 7. So 4 and 3. If you carefully see, you will say. So 7 matches, not 7.5. That 0.5, just check carefully. Now, how many matches India won in 1998 against Australia where Sachin played? Four matches India won and 3 matches. Red is 3. 3 matches Sachin. So I can get this kind of a picture. If you require, not all of us will require. Yeah, Pritam, I hope I can share the video with you. So let's see. Even my this thing was crashed. So let's see. I hope the video is there. So this kind of charts can be created. Now, when these for basic charting, I would not ask you to do R, but for this advanced type of charting, R comes in handy pretty well. So this is actually, you see, all the 4 sides have different axes, right? Okay, close it. Scroll down just 1 minute. So how much did we do? So it's the same thing with a different facet. Just run this last line, I would say. So first 2 lines you run up to 143 to 145. 143 to 145. Okay, one by one you learn whatever you did in the last also. Run it. 143, then 144, 145. I have created some subsetting. Then what did I do? 146. Run it. So this is how many India first innings and second innings he played and how many different kind of dismissals he had. Go ahead. So this scale brewer actually breaks it into 2. Instead of stacked, it will create 2 other bar charts. Go ahead. Now only based on innings. See, previous one I didn't do based on innings. Okay, wait. You have run 2 lines. 148, line number 148, please. So 148 breaks into 2 innings. What does 147 does? Yeah, sorry. So this one we missed. So instead of fill is equal to innings, what here we did is scale fill brewer, means we have actually made the color variations. If you understand what this means, that when for 1 there will be a different shade of the same color and 2 there will be a different shade for a same color. So instead of 2 different colors, 1 color but 2 different shades. Okay, now line number 148. So facet wrap, this we have seen, 149. So see what we did is coordinate flip. So you change the bar chart to the column chart to bar chart, basically. Coordinate flip you are doing. Other things the same. Go ahead. 150. Theme panel background, I'm bringing in some background effects with the fill to be blue. And last 151. The panel, the whole panel can also have some color, which looks very bad, but I am showing you that you can color it out. So this I would suggest, that's all for today. I would suggest that you go ahead and play with it and try to create other kind of charts with the data sets that you have and see that whether you can create. So facets and these themes are very interesting. Try to see that whether you can create different kind of interesting charts from there or not. So ggplot is something which can do many stuff, and all you have to do is understand the small codes and copy and paste those codes, frankly speaking, not anything else. So you can try to do that. So that's all from today. If you have any doubt, you can ask me, and we will be meeting you again in the next class, which is tomorrow. Yes, Anindo, you can ask me. If anybody has any question, you can PM me. Anindo, it's open for you. Otherwise, we are done. You can leave. So that book that I told, the book name that I gave you.
Hi, good evening.
Hi, tell me.
Yeah, actually, I'm going through that assignment part, that coding that you have given in the assignment.
Yes.
So in that, there is one difficulty that I was facing, that how to sort the entire data set and to get a subset of the complete data.
So do you want to share your screen?
Yeah, give me a couple of minutes. I just load that program.
So Anindo, I will not tell you the answers, frankly
No,
speaking.
that's fine. That's fine. So my question is, here in today's class, we have discussed about that subset subset that function.
Yes.
So can we do that? Means do
Try
that
that also.
using.
One copy. I would suggest you copy from there and change it according to your need.
Okay. Because I was referring that book you have given, that cookbook for the R. So in that there is no exact thing is mentioned that how to sort. Means basically I am facing a problem is it is an asymmetric. The data is in the asymmetrical order. So if I need to sort the entire data, first thing is, can I fragment it into a different data frame, individual column?
Why do you want to do that?
Then how could I sort the entire means whatever we do in the Excel, we put a filter on the.
Anindo, let me ask you that.
Okay.
If you don't know a function, the availability of a function in R, what will you do? If you don't even know that whether this can be done by a function or not, what will you do?
Then I have to create a function.
Before creating a function, you do not know what are the various functions available in R. There are so many functions available in R. You have no idea about them.
Right.
Where would you go to find them?
Yeah, we can go through either the cran dump means R help or in the Google.
You can go to Google. So why don't you go to Google? Can help will be required only when you know the function name. You don't know the function name. Why don't you go to Google, search in Google that how to order a data. What are you doing? You're sorting the data, right? Based on a column.
Right.
Just go and search. This is the work. That itself is the work that I've given you. That go to and search in Google, find out a code, try that code in your data, whether that works or not. You will not be able to do it on your own without knowing the syntax of the codes. So there is a function called order. There is a function called do by, which can do all of these things. But I will not want to say that. I want you to find out that the sorting pattern. Okay. Why don't you go to Google and search how to sort a data in R?
Okay. Let me check once. I'm not find it in that way.
We'll again meet tomorrow. The assignment is another 7 days left, so we will again meet tomorrow and then we'll.
Yeah, that's fine. I'm just going through all the questions, so there was a stuck basically to sort the entire data set and everything.
Yeah. So the idea is that if you get stuck, try to Google it out, because you will not get a book or something to handhold you every time. You have to believe on the crowdsourced information source.
Okay, thank you.
Okay. Okay, for the rest of the guys, I will just check your results. Don't worry, I will check all the submissions one by one. I will give feedback. So please submit. You have time. You have another 6 days time. Please submit. Okay, thank you for today. I will see you tomorrow.